What are angles? We have encountered several physical quantities which have dimensions like length or area or volume. Angles are different in the sense that they don't really have a spatial dimension that we can define, right? There is no size for an angle. Let me explain to you what this means through a simple thought experiment. Let's say we are dealing with a circular track. So it looks something like this. And we have people moving on this track. So we have runners moving on this track. And we are numbering them from the inside to the outside. So we have runners 1, 2, 3 and 4. Let's say these runners are following the track round and round in such a way that if I were to look at them from the center of the track, I am observing these runners from the center of the track, they always seem to be running right next to each other. So it does not matter where I look at them, all these runners are at the exact same distance from each other. But this raises a question, are they all moving at the same speed? Their velocity is changing because their direction of movement is changing, but are they moving at the same speed? To see if this is true, let's look at the interval of time between this point A and this point B. We are observing the movement of these runners between these two time intervals. We see that runner 1 is covering this distance shown by the dashed line in this interval of time. Let's call this interval of time delta t. So the runner 1, let's say, is covering the distance of d1 in this amount of time. Runner 2 is covering this distance. Runner 3 this distance and runner 4 this distance. You will observe that the 4 distances travelled by these runners are clearly not the same. It can be seen that runner 4 has covered a greater distance in the same time interval compared to runner 1. So clearly the 4 runners are not running at the same speed. Regardless of this, they always seem to be running in line from my perspective at all points in this journey. They always seem to be together, which means that from my perspective, there is some quantity that is remaining constant, and that quantity is what we call angle. An angle is not a length, it is not an area, it is not a volume. It is not really a spatial dimension, but in fact, it is the ratio of two dimensions. And the reason is this. If we look at the distance at which the runner 1 is from the center, we can call this distance R1. We can call it R2 for runner 2. We can call it R3 for runner 3 and so on. So the 4 people, the 4 runners are running at different distances from the center of this track, from the point where I am observing them. And in a period delta t, this distance from the center is not changing. The distance between me and runner 4 always remains R4 at all points of time. The distance between me and runner 1 remains R1 at all points of time. However, we notice that D1 is less than D2, is less than D3, and that is less than D4. Runner 4 is covering more distance in the same interval of time compared to the other runners. So how can we find this quantity that is same for all of these runners? We can do that by getting the ratio of the distance that these runners have covered to the radius or the distance they are holding from the center of this track. So we can get the ratio between D1 and R1, D2 and R2, D3 and R3, D4 and R4. If you were to actually perform this experiment and find out these ratios, you would discover that all 4 ratios are equal to each other. The ratio of the arc covered by any one runner to his or her distance or radius from the center of the track always remains constant within a given interval of time. This ratio, the ratio of arc length to radius is what we know by the name angle. So angle is not really a spatial dimension the way we understand other spatial dimensions or other spatial quantities like distance or volume or area. It is actually the ratio of two lengths, the arc covered and the radius of the circle that we are measuring. So what is the mathematical way of defining the degree? Let's look at something that we call the unit circle. Let's say that we have a circle and we consider the radius of this circle to be 1 unit. So this is exactly 1 unit. Now you could ask, sir, what do you mean by this term 1 unit? Well, whatever system of measurement you are using, this length represents 1 unit of that system. This can be a kilometer, this can be a micron, this can be a light year, but it represents 1 unit of that measurement system that you are employing. So the radius of this circle is exactly 1 unit. If we were to apply the basic formula for the circumference of the circle, we find out that this distance, that is the circumference of this circle, is equal to 2 pi r, that is equal to 2 pi units. So this is the length of the arc of this circle. So let's say I were to start my journey at point A and I walk all the way across this circle and I reach point A again. The question is, what is the distance I have covered? Well, it is clearly 2 pi units. But from the perspective of someone, or let's say my friend is standing at the center, if they had to answer what is the total distance that you have covered, that would have a simple answer. But if we had to ask them, how much did you have to turn in order to follow me? That is not simply measurable. We do not have a single quantity that can give us this answer. We can only express that as a ratio of two quantities. So in this case, the angle that I have swept for one complete trip around this track will be equal to the angle will be equal to the arc that I have covered divided by the radius of this circle. And if I were to do this calculation, that gives us the angle is equal to 2 pi units, that is the total arc that I have covered in one complete journey, divided by 1 unit, that is the radius of this unit circle. That gives us an answer equal to 2 pi. But 2 pi what? What is the unit that we will use here? The unit that we use, the SI unit for angle measurement, is the radian. So I have covered exactly 2 pi radian. If I were to cover only a quarter of this circle, so let's say that I covered a journey from point A and ended that journey at point B, what would be the angle through which I have moved? What would be this angle? Well, let's use the same definition again. In this particular case, the arc that I have covered is not 2 pi units. It is a fourth, a quarter of 2 pi units. So that will be 2 pi units divided by 4, that is pi by 2 units. This is our arc. And the radius is again 1 unit. So in this particular case, this angle comes out to be pi by 2 units divided by 1 unit, that is pi by 2 radians, which we otherwise call 90 degrees. Now you could ask me, sir, why do we have to follow this complicated system of measuring angles with radians when I can just use degrees? I have been using degrees for a long time. Well, here is the problem. There is nothing intrinsically wrong with using the degree measurement, but we should remember that the only reason we say that a circle has 360 degrees inside it is because 4,000 years ago, some Babylonians discovered that you could find 365.25 days in a complete solar year, the time it takes for the Earth to complete one circle around the Sun. So 360 was a number that they could use very easily because they had base 60 arithmetic 365 and 360 are very close to each other. That is the only reason we use 360 degrees in one complete circle. So this is a very arbitrary measurement. If you were living on Mars or if you were living on Jupiter, you would be using a different measurement because the length of a year on those planets is different. It is not 365 days for Mars or for Jupiter. For Pluto, it is more than 200 years. So what do we do then? The beauty of this method of measurement is, since the angle is always a ratio of the arc length to the radius, it will always be expressed in the exact same way. It doesn't matter whether you are using kilometers or nanometers or light years, as long as the unit system remains consistent, you will always get the correct answer. This is why we prefer the use of radians in physics in contrast to degrees. Now, this was the case for an object which is moving in a plane on a 2D surface. We can also define the concept of angle in 3 dimensions. For example, consider that we have, let's say, a watermelon. So we have a watermelon. If I were to slice a cone out of it, it would look something like this. So if I were to slice out this cone, it would have a rounded outer surface, something like this, and I would be able to slice it out of this particular sphere or this watermelon. The question is, how can I define this quantity without having to use volume or surface area? Well, just as we used the ratio of a arc length to the radius of a circle, we can advance this idea into 3 dimensions. We can define a new quantity which we call the solid angle. The solid angle is equal to the area of the outer surface that you have sliced. So we are referring to this particular area and taking the ratio of that to the square of the radius of this slice. So we are taking the radius and we are squaring that. So that gives us the solid angle for this particular slice. Now remember, the dimensions for area are length squared. So if you take the area on the numerator and in the denominator we have the radius squared, that is again a length squared. So the units will cancel out. Whatever units you use, feet, meters, paces, doesn't matter. The units will cancel out. So you are left with a pure ratio, and that is the solid angle. It is measured using a unit called the steradian. We use radians for normal angles, and for solid angles we use steradians. In the case of a circle, we realize that one complete journey corresponds to 2 pi radians of normal angle. How do we find the equivalent of that for solid angles? Well, for, let us say we have a unit sphere, right? For a unit circle, we say that the radius is 1 unit. Again, we take that idea and we bring it into 3 dimensions. For a unit sphere also, the radius is equal to exactly 1 unit. What is the surface area for this particular system, for this particular object? It will be 4 pi r square. What is the radius of the sphere? It is r. The square of the radius is r square. So the solid angle for a sphere comes out to be the ratio of 4 pi r square to r square. They cancel out. We get 4 pi steradians. So the total solid angle for a sphere is 4 pi steradians. Now the reason that we have defined the solid angle is, in physics there are many quantities which are spread out over large volumes, which are being emitted by a volume or going into a volume. For example, the light being emitted by a star, or the electrical field that is being emitted by a point charge. These problems have spherical symmetry, and using the solid angle greatly increases the chances that we can get our answer easily and quickly.
Manorama Horizon. Learning made simple.